Today's seminar is going to be on volume and surface area, and our goal or I can statement for this lesson is I can find the volume and surface area of prisms, cylinders, and cones. So go ahead and pause the video at this time and copy this title as well as the goal into your notebook. Alright, the foldable that we have for today is going to look like this. So we're looking at 3D geometry. And the main focus is volume and surface area. Some of the things that we'll be looking at are volume of prisms and cylinders, volume of pyramids and cones, surface area and prisms of cylinders, prisms and cylinders, and surface area of pyramids and cones, and last but not least, doing some measurements in 3D figures. So let's go ahead and get started then with the volume of prisms and cylinders. So first and foremost, let's go ahead and look at some formulas here. So when we're looking at volume of prisms and cylinders, we have a couple things that we need to look at. So the main formula is volume equals base times height. And what a big B means when we're finding volume is that whatever the area of the base is. And I have those listed down here. So if it's a rectangular prism, it would be base times height or length times width as you would normally see it. So this B could be length and width as well. For a triangular base, it'd be 1/2 base times height. And for a cylinder, it would be pi r squared. So whenever you see a big B, it's not just whatever the base is, it's whatever the area of the base is. So keep that in mind. That will be necessary throughout today's lesson. So let's first and foremost start with the example 1 here with the rectangular prism. So we know that we are going to have problem volume equals, I'll change this to length times width because that's what we're used to. So length times width times height. So we should always write down whatever the equation is first before we start working with it. And then we also need to fill in here volume equals, so length would be 2, width is 3, and height is 4. And really, however these are arranged is not that big of a deal because you're multiplying all of them. Multiplication is commutative, so it works either way. So then let's say volume equals, well, 2 times 3 is 6, 6 times 4 is 24. And last but not least, we need to make sure that this is labeled correctly. So inches cubed. And the reason we say cubed is because we're trying to figure out how many 1-by-1 unit cubes fit within this structure. So that's why we're saying inches cubed. So 24 1-by-1 inch blocks would fit into this prism here. So that's our first example. Let's look at example 2. So this would be a triangular prism. So what we need to do then, we're looking at volume equals base times height, but our base in this case is going to be 1/2 base times height. So if I write this out, it's going to be volume equals 1/2 base times height times the height. So make sure you have that written down. And then let's fill in what we have here. So volume equals 1/2. The base of this one is going to be, well, we're looking at the triangle here, so the base is 8 centimeters. 1/2 times 8 times the height of that, which is 7. And then you're looking at the height of the prism itself, how tall it is. So if we stood this up, it would be 13 centimeters tall. So times 13 over here. And we just have to carry out some order of operations here. So 8 times 7, that's going to be 56. And then if I do that times a half, using a calculator is completely fine on this. So we would have 28 times 13 equals 364 and centimeters cubed. Make sure that you're labeling your answers and you're showing work like this, working down through the equation. This is what I expect to see when you're doing these types of problems. So make sure you're doing that. It's much easier to look through your work to make sure you have everything correct, and if you made a mistake, it's easier for me to see where it is. So please follow that and use this type of work. Last but not least, we have a cylinder here. So again, we're still looking at volume equals base times height, so whatever the area of the base is times the height. Our base in this case is a circle, so the equation we would have is volume equals pi r squared, and then that is times the height. And we're just going to have to fill in everything we need here. So we're going to need the radius and we're going to need the height. So V equals pi. Radius squared would be 4.2 squared. And then times 7.5 since that's the height. Now it says here use 3.14 for pi, so I'm just going to rewrite this again. 3.14 times 4.2 squared times 7.5. Order of operations matters here. We're going to have to do this 4.2 squared first, so let's go ahead and do that. So that's 17.64. So 3.14 times 17.64 and times 7.5. So again, you can use your calculator on this. And on these, I would round to the nearest tenth. So volume in this case is going to be 415.4 millimeters cubed. Remember, it's volume, so it's cubed. So that's our first look at volume here, and this one was of prisms and cylinders. So we're going to move on to the next part. If you need to pause the video here in order to copy this down, I would do that real quick before we move on. All right, moving on then. Next, we're going to look at volume of pyramids and cones. So a little bit different here, but not much. The only thing that changes is that we're now looking at 1/3 in the front. And the reason we're looking at 1/3 is because this pyramid, if this were to be just a rectangular prism, 3 of these pyramids fit into one regular rectangular prism. So that's why we're dividing by 1/3. The same case is true for a cone. It is 1/3 the size of a cylinder. So that's where the 1/3 is coming from, in case you've ever wondered that. So let's start with our first one here. Again, we have the big B, remind you of your areas of your bases that you're looking for. So rectangular is base times height, triangular 1/2 base times height, and cone would be pi r squared in this case. So let's go ahead and do this one then. Volume equals 1/3 big base times height. This one happens to be a rectangular base. So that means we're just using the length times width times height. Again, I'm going to change this here. Length times width so that it's more consistent with what you've seen, but base times height is the same idea as length times width, just different labels. So volume equals 1/3 length times width times height. So volume equals 1/3. My parentheses in here, and we'll fill in our numbers. So length, I would say, is 6. Width is 5, and height is 7. Again, we just have to do some multiplication here. So 6 times 5 times 7, which is 210, but we have 1/3 of that. This is the same as dividing by 3. 210 divided by 3, so 70 meters, and this is volume, so it is cubed. 70 meters cubed fits in that, inside of that pyramid there. So let's go ahead and try example 5 then. You're going to have a triangular base on that one, so your big B that's in here is going to be replaced with 1/2 base times height. So V equals 1/3 times 1/2 base times height, and again times the height of the pyramid. So this is a triangular pyramid. Let's fill everything in. So we need the base and the height of the triangular base, 1/3, and this is all multiplied, so I can separate this. 1/2, base is 9, height is 5, and the height overall is 8. So it's just a big long string of multiplication there, which is not a problem. So 9 times 5 times 8, 360. And really when I do 1/3 and 1/2, that's 1/6 when we multiply. And then 9 times 5 times 8 is 360. This is just like dividing by 6 here. So 360 divided by 6 is 60. So this is 60 inches cubed. That's the volume there. So really all it is with volume is understanding the formula and knowing where to put your numbers. That's all it is. Other than that, it's just basic multiplication and addition. So then let's take a peek at this cone here. Volume equals, so in this case we still have 1/3 out front. Now we need to put in pi r squared though, and then that's times the height. And the reason we put in pi r squared is because our base, our big B that we have here, is a circle, so we need to take the area of that base, which is pi r squared. Equals 1/3. They say use 3.14 for pi, so I'm going to do that. Radius is 4.2, and that's squared, and then times the 8. Remember, order of operations, we have to do the 4.2 first because that's a exponent. So that's 17.64. So I'm just going to replace everything in here. 1/3 times 3.14 times 17.64 times 8. I'm going to keep that 1/3 out front here. And then I'll do the rest of the multiplication. The 3.14 so that's 443.1168. We'll round to the nearest tenth at the end here, so that divided by 3 is 147.7. So we'll round to the nearest tenth, like I said, yards cubed. So similar to the volume of prisms and cylinders, the only difference is that you're dividing by 1/3, and the reason for that is that 3 of each of these would make up their parent figure, which would be the rectangular prism or the cone, or cylinder, not the cone. So go ahead, if you have to pause the video here to write down these examples, you can do that. Otherwise, we'll move on to surface area now. Alright, so first and foremost, we have formulas here that we're going to have to use in order to do this. So for a rectangular prism for surface area, you have 2 times the base times the height. So the base times the height would be these front and back faces of this. 2 times the base and the width, so that's 3 times 2, and times 2 because the top. And then height and width, which would be the 2 times the 4, which we didn't have yet. And really, just as long as you get all 6 faces of this taken care of, shouldn't be a problem. Triangular prism, this is one that, yeah, you have to do this. What this P means here is that you're taking the perimeter of the base, so whatever it's sitting on, times the height, and then 2 times the area of the base. So that big B, remember, is always the area of the base. And then a cylinder, which is probably one of the more complex ones. You have surface area equals 2 pi r squared plus 2 pi r h, and we'll get into the reasoning why on that here in a second. But let's start with example 7 up here. And we have a rectangular prism. So what we're doing is surface area equals 2 times the base times the height plus 2 times the base times the width plus 2 times the height times the width. Surface area is a little bit more involved because there's more pieces to these problems. Now let's fill in everything that we need to here. Finding an example quick. Sorry for the delay. So, base and the height would be 3 times 4. So 2 times 3 times 4. Plus, the base and the width would be 3 times 2. And finally, plus the height and the width, which would be your 4 times 2. 2 times 4 times 2. So let's go ahead and carry all those out. Well, 2 times 3 times 4. Some of these we can just do mental math. 2 times 3 times 4 is 24. Plus 2 times 3 is 6 times 2 is 12. 2 times 4 is 8 times 2 is 16. So the surface area would be 24 plus 12 plus 16 is 52, I believe. Yep. 52 inches squared. Now remember, these are squared because we're finding area. How I remember that is squarea. Just another goofy thing I say for you to remember. Alright, so that is the surface area of a rectangular prism. The next one, the triangular prism, is going to be a little bit different. So surface area equals, and our formula's up here, the perimeter of the base times the height plus 2 times the area of the base. So one number that we're missing here, we don't have, I'm sorry, that's down there kind of low. We don't have this length of this side or down here. I'm going to tell you that it's 10. The reason it's 10 is when I apply the Pythagorean theorem, I'm able to figure out this length here, the short part and the height, and that gives me 10 when I do that. So in this case, it's just 10. Normally, they probably label that for you. This one just has an extra step that I'm just going to give to you. So surface area equals perimeter of the base. Remember, perimeter is the distance around. So we would call this our base down here. So that's going to be, and we'll add those together. So 12 plus 10 plus 14.9. This is going to get kind of long, times the height, which I believe is, let me just find my example here, 20. Yep, it's going to be the height of the prism, times 20, and then plus 2 times the area of the base. So that's going to be, your base is triangular, so it would be 1/2, so a lot of multiplication going on here, times the base, which would be 14.9, and then times the height of that, which is 8. Apologize, that's a little bit sloppy. Let's clean it up a bit here. Surface area equals, so 12 plus 10 plus 14.9, that's 36.9 times 20, plus, let's do 2 times 8 times 14.9. Let's divide that by 2. And then I think we need to, hold on a second, 2 times 8 times 14.9. And then we need to do that divided by 2, like I said. Yep, so that would be 119.2. That's this whole part here done. And then surface area equals, let's do that, 36.9 times 20 plus 119.2. And that would give us 857.2 millimeters squared. So that's the surface area of that triangular prism. Remember that P is the perimeter of the base, and this is labeled on another page, so you'll have that. And then base is the big B is whatever the base of the area of your base is. All right, let's go ahead and do this cylinder then, and then move on after this. So surface area equals, and this is a longer equation, 2 pi r squared plus 2 pi r h. And I'll explain how this equation works here in a second, but I do want to get everything filled in here. So we need radius and height, which is everything we have. So surface area equals, and they say use 3.14 for pi, 2 times 3.14 times radius is 3 plus 2 times 3.14, and I'm just going to come down here. Remember, they're multiplied together. Radius is 3 and height is 4. So where we get the 2 times the pi r squared, that's the 2 circular bases. That's where we get those. Why we have this 2 pi rh is because, think of this as like a soup can. If I unwrapped the label from it, I would have a rectangle. We have the height of the rectangle. We know that's 4, but the distance around that label, so the length of that rectangle, would be the circumference of the circle. So that's where 2 pi r is coming from. So just some background on that. So I'll carry out the multiplication here. Remember, you have to take care of this first, that 3 squared. So 2 times 3.14 times 9. So I just did that in my head and knew that was 9 and multiplied it. So that first part is 56.52 plus 2 times 3.14 times 3 times 4 is 75.36. So add those together. Again, calculators are fine. And what we get is, and I'm going to round this to the nearest tenth again, 131.9 centimeters squared. Remember, it's squared because we're doing the surface area. Area, not volume. So those are your 3 examples here for that. And let's move on quickly then to the surface area of pyramids and cones. If you need to pause here and copy this, go ahead. Pyramids and cones. Let's go ahead and work through this then. And then you'll have a few problems that I want you to try on your own, and then you'll have time to do your exit slip. So some formulas here that we need. So rectangular and triangular prisms for surface area is 1/2 the perimeter times the slant height, which is down here L. Slant height is going to be like this here. And then plus the area of the base. Now these couple problems, you don't explicitly have them in ALEKS, but it doesn't hurt to understand these formulas. So that's why I'm giving them to you. Sort of an advantage. And then for a cone here, we have 1/2 times the circumference and times the slant height, which they give you, plus the area of the base. We have to think about that again. What's the area of the base of a cone? So let's get through these real quick. So up here we have a triangular prism, so we're using surface area equals 1/2 perimeter of the base times the slant height plus the area of the base. So let's fill everything in we need. So surface area equals 1/2. Perimeter would be 4 plus 4 plus 4 plus 4. So that's 16. I'm just going to fill that in. You could put 4 plus 4 plus 4 plus 4 in there, but I'm not going to. L is the slant height, so we know that that's 5. Plus the area of the base, which would be 4 times 4, which would be 16. So, just about there. Carry out our multiplication. 16 times 5 is 80. Divided by 2 or multiplied by 1/2 is 40. Plus 16 more would be 56. So 56 inches squared on this one here. So as long as you can fill in the parts of the equation, or the formula I should say, you're in business, because the rest is just multiplication and addition. Then let's do number 11 here. So again, this is a triangular prism. Lots of numbers going on here. So we've got to make sure that we get this one filled in correctly here. Find my sheet real quick. All right. So we have the same idea here. So surface area equals 1/2 perimeter of the base times the slant height plus the area of the base. So that means surface area equals 1/2. Perimeter would be 12, 12, and 12. So 36, because I'm just going to add those up right away. Slant height is going to be this 6. That's going up because it's slanted. The base one isn't. So it's going to be 6. And then the area of the base is a triangle, so we have 1/2 base times height. So I'm going to have another half. Base of that is going to be 12. Height of that is 10.38. And again, carrying out the multiplication and addition, which is pretty straightforward as long as you follow the order of operations correctly. So 36 times 6, and we're going to divide that by 2, or multiply by a half. That's 108, plus 12 times 10.38, so 124.56, but we need to divide that by 2, or multiply by a half. 62.28. So surface area equals 170.28. And we'll round, like I said, to the nearest tenth, so 170.3 meters squared. So not too terribly difficult to work with. And let's do number 12 here before I have you try examples on your own and then get to the exit slip. So the equation we need here is, we can find that there, so surface area equals 1/2 times the circumference, 2 pi r, times the slant height, which is listed as the L, plus the area of the base, which is going to be a circle. So let's fill in what we know. Surface area equals 1/2 times 2 and 3.14, because we're using that for pi, times the radius, which is 3. Slant height is the 10 here, because it's that slant. And we still have to add the area of the base, which is going to be pi r squared. So 3.14 times 3 squared. Again, just a bunch of multiplication, so I'll do that first part, which is 2 times 3.14 times 3 times 10. So first part is 188.4 plus 3 squared is 9. We have to do that first, so 3.14 times 9 is 28.26. Add those together, equals 216.7 centimeters squared, remember, because it is area. So again, if you need to, go ahead and copy down these problems. Make sure you have them, as you can reference them when you're doing any of these topics, or your weekly assignment, seminar sheet, whatever it is. So if you need to pause here, copy that, do that. Otherwise, if not, then there are 4 examples that I want you to try on your own before you go on to finish your exit slip. And so you have surface area in 13. Just zoom in here. Surface area of 13. Volume here on number 14, and on 15 you have volume, and 16 is also volume. So just one surface area problem here. The catch here though is that it's asking you to convert. So instead of millimeters here, you have to do square inches. Instead of inches here, cubic centimeters. Instead of centimeters here, you have inches, and instead of meters here, you have feet. So you're going to have to look up those conversion rates. You can still solve it normally here, but at the end you'll have to convert. So go ahead and pause the video, try these examples, and then once you've done them, you can play it and you will have, I will write the answers down for you. I'm not going to do them for time's sake, but you will have the answers for you. So like I said, pause the video and then go from there. Alright, so you should have finished doing these 4 examples. In example 13, you should have gotten 3.08 inches squared. On 14, you should have gotten 98.3 centimeters, and this is cubed. On 15, the answer that you should have gotten is 22.1 inches cubed. And last but not least, on 16, you should have 239.6 0.6 feet cubed as well. If you didn't get any of those correct, please go back and fix them. It's important to practice and find your mistakes. So please do that, and then you can move on to doing your exit slit. Other than that, that concludes the foldable for today. Make sure that gets put in your notebook as always. And just a quick recap of our goal for today. Again, we did volume and surface area, and our goal or ICANN statement was, I can find the volume and surface area of prisms, cylinders, pyramids, and cones. If you have any questions, you can always replay the video, pause the video. Otherwise, I am always available for questions.